Nature is shaped by invisible fields like magnetic forces, wind currents, and the fluid motion of water. In games like Ghost of Tsushima, the wind isn't just an atmospheric effect, it's a guide. It's an invisible force field that tells every leaf and blade of grass exactly which direction to move. We call this a vector field. When you look at code like this, you aren't just looking at numbers. You're looking at the physics of a living world. Hi everyone, I'm Amlan Pati. Today we are going to bridge the gap between applied physics and generative art. We are going to build our own wind map from scratch. To understand wind, we have to understand the vector. A vector is just a piece of data that has two things, a direction and a magnitude. Imagine our screen is a giant floor covered in invisible conveyor belts. Every square on this floor has an arrow pointing in a specific direction. When a particle lands on a square, the conveyor belt pushes it. If we coordinate these arrows correctly using math, we get a flow. In physics, this is how we model fluid dynamics, magnetism, and, you guessed it, wind. We are keeping this pure. Vanilla JavaScript and the HTML5 canvas. I'm using Emmet abbreviations in VS Code to skip the boilerplate, a quick shortcut to generate our structure. We add a few lines of CSS to make our canvas fill the screen and set our background to black. This is our blank world space where the physics will live. Physics engines are built on state. We need objects to track. We are creating an array of 1000 particles. Each one is a simple object with a position x and y and a velocity dx and dy. Notice that we aren't using a complex class yet. We are keeping it simple so we can focus on the motion. At this stage, if we draw them, they are just static dots. They have potential but no instructions. Let's look at how we actually move these particles. The simplest way is just adding a fixed number to x and y every frame. It works, but it's rigid. They move in one direction and they're gone. To get more control, we introduce velocity vectors. Instead of hard coding numbers, we use Vx and Vy. This allows our particles to have their own unique speeds and directions, which we add to their position every frame. This is basic kinematics. In the real world, our eyes have persistence of vision. We can simulate this by not clearing the screen entirely. Instead, we paint a 5% transparent black layer over everything. This trick is called alpha blending. This leaves a trail of where the particle was. Suddenly, the invisible vectors become visible paths. We have turned raw math into generative art. Now, the Ghost of Tsushima moment. We don't want them moving in straight lines. We want them to follow the wind. We calculate an angle based on their position using trigonometry. We use cosine for our horizontal push and sine for our vertical push. Suddenly, they're swirling. But the logic for our flow field is finally alive. The version we just built is the foundation. On my GitHub, I have uploaded an advanced version where I have added HSL color shifting and a few tweaks to make it look even more like the guiding wind from our intro. In the next video, we are going to give our mouse a gravitational pull and learn the math of interaction. Like, share and subscribe, and I'll see you in the next one.